Welcome to another fantastic edition of Comet Algebra. This video is for Algebra 1, Chapter 11, Section 6, titled The Pythagorean Theorem. But this section really has three parts. In addition to Pythagoras, we will be looking at the distance formula and the midpoint formula. So let's get started. First, some terms, and I'm going to go through this Pythagorean kind of quick because I know you've seen it before in pre-algebra. So first, a right angle is a 90-degree angle. A right triangle is a triangle that happens to have a 90-degree angle in it. The legs of a right triangle are the two sides that touch the 90 or make up the 90, and the hypotenuse is the side that's across from the 90. And I'm just going to draw a quick sketch of this. In a sketch of a right triangle, the right angle must always be labeled because we can't just count on eyeballing it. So if that's the 90, that makes this a leg of the triangle, and this side is a leg, and this side we call the hypotenuse. The hypotenuse is across from the 90, and it is the longest side. The word theorem is a statement, and we use this for math statements all the time, that we have proven are always true, and then we can use them in our problems. This theorem was discovered in ancient Greece by a guy named Pythagoras who was working on triangles, and he discovered that if he measured the length of this side and squared it, and measured the length of this side and squared it, and added those together, it always added up to the square of the hypotenuse. So a and b in the formula, a squared plus b squared equals c squared. A and B are the legs, and C is always the hypotenuse. So please take note of that. A quick example here too. Find the length of side B. So this is what we're looking for. So we notice that this is a leg and this is a leg here. So I can write B squared plus 12 squared equals 15 squared. And note, the 15 is the hypotenuse. It's across from the 90, so that's the big side. So we square both the 12, getting 144, square the 15 and get 225, and then subtract 144 from both sides, giving us an 81. Now we learned that to solve this, we take the square root of both sides, or maybe we haven't done that section yet. But the opposite of squaring something is square rooting. So to undo this, b squared, we simply square root both sides. And even though the square root of 81 really does give us two values, it gives us the positive 9 and the negative 9, because this is a measurement. This is the measurement of this side. We can reject the negative 9 because a measurement can't be negative. So that leaves us saying that b is 9 units. Very often this is not a perfect square, so you can express lengths in a square root form, or sometimes the problem might ask you to actually take the square root and round to the nearest tenth. So just read the directions carefully what we're supposed to do. In example 2, we're asked to find the length of the hypotenuse, to find this c. That means that 10 and 20 make up the 90, so these two are the legs. Therefore, when you plug them in, it'd be 10 squared plus 20 squared equals c squared. Squaring both of these, 100 plus 400 equals c squared. Adding them, we get 500 equals c squared. Taking the square root of both sides gives me square root 500 equals c. And the square root of 500 is not a perfect square, but it can be reduced. I see that it has a square root of 100 in it. You know how I do that sometimes? I just write it above here so visually I can see. 500 is 100 times 5. This is a perfect square, so it's going to come and live out in front. So the simplified radical of this is 10 square root 5 for the hypotenuse. The next thing we're going to look at in this video is the distance formula. Now the distance formula comes from the Pythagorean theorem, and in class we're going to go through how to derive it from there. But for the video, I'm just going to give you that distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And you can see if you would square both sides, this sort of looks like Pythagoras. to say that d squared equals this quantity squared plus this quantity squared. So the 2 points here, don't let the subscripts, intimidate you. x1, y1 is just any ordered pair on the xy axis, and x2, y2 is another ordered pair. Like they could be one ordered pair could be here and one could be over here. And this distance formula simply finds the direct distance between them right here. And it doesn't matter which one you call x1, y1 and which one you call x2, y2. Again, just like slope, be consistent. If you start with the x2 with your subtract with the x's, you must start with the y2 when you're subtracting the y's. So let's try an example. We're asked to find the distance between these 2 points. And again, it doesn't matter. I'm just going to happen to choose that this is x1, this is going to be y1, this is x2, and this is y2. And I like writing it above there just so I can keep it straight. So now let's plug them into the distance formula. Let's give ourselves a nice big square root. So the first is x2 minus x1. So I chose x2 to be -4, and x1 is -2. So is that okay? I'm subtracting a -2, that double negative. I'm going to go ahead and write +2 so the double negative doesn't confuse me. Now in between these 2 parentheses is a plus sign. And now I have y2 minus y1. y2 is 4 minus, again, I'm subtracting a -3. So is that okay if I just write +3 and squared? So check my negative signs there and make sure you agree. Now we need to be very careful about following PEMDAS when we do this simplifying here. You do need to go ahead and add or subtract these numbers first. So -4 plus 2, I'm going to try to show you all the steps, and you'll probably be skipping some of these steps when you get familiar. But that's a -2, and we are squaring it. Plus 4 plus 3 is 7, and we're squaring that. So now let's go ahead and square these numbers. -2 squared is +4. 7 squared is 49. And now you go ahead and add under the radical. This gives us the square root of 53. And I'm looking for any factors here to possibly simplify this, and I'm not seeing any. So the distance between these 2 points is in radical form, the square root of 53. And if we could punch this out on the calculator, and if we rounded to the nearest tenth, we would get that this distance is 7.3 units. The last thing we're going to look at in this video is the midpoint formula. And it's just finding the middle of a line segment that has an endpoint of x1, y1, and the other endpoint is x2, y2. And we simply add the x coordinates together and divide by 2. And this is written in a comma and parentheses format because the midpoint is a location on the graph. So you're finding the x coordinate of the midpoint, and then you're finding the y coordinate. So your answer is an ordered pair. Like I said, you're adding the 2x and dividing by 2, and then this is a comma, adding the 2 y coordinates together and dividing by 2. And my comment for you is, doesn't this kind of look like you're taking the average between the 2 x's and the average between the 2 y's? Because it is. Taking the average finds the middle. All right, this is just an example, an illustration, if you will, of the midpoint formula, with A and B being the 2 ends of the segment, and this point M here is the midpoint. I'll label it M. So you can see that it's just x1, y1 is one of the endpoints, x2, y2 is the other one of the endpoints, and you simply average the x's to get the x coordinate of the midpoint and average the y's to get the y coordinate of the midpoint. So let's look at an example of this. So again, the midpoint is an ordered pair. So let's add the 2 x coordinates to find the x coordinate of the midpoint. I should say add them together and divide by 2. So I have -2 plus a -4 divided by 2. And I'll just put a comma here to separate my x and y calculations. The y's are negative 3 plus 4, again, dividing by 2. So now doing the math, I get negative 6 over 2, comma, and I get 1/2 here. And this leaves me with the midpoint of negative 3, comma, 1/2. So now you have the knowledge you need for section 11.6. So have fun with math.